Good day, learners. Welcome to Mathematics lesson. My name is Nonkulule Gumbuisa. This lesson is brought to you by Sci-Bono Discovery Center in collaboration with Gauteng Department of Education. In today's lesson, we'll be looking at trigonometric functions. At the end of this lesson, you should be able to understand the effect of parameter P for the graph of sine, cosine, and tangent. What you should be knowing, you should be knowing how to sketch the trigonometric graphs. You should be knowing how to use your calculator to sketch the trigonometric graphs. You should be knowing what is a Cartesian plane. You should be knowing where are the x-axes and where are the y-axes. You should be knowing the effect of parameter A and the parameter Q, of which is what you have done in grade 10. Remember, in grade 10, we spoke about the parameter A, of which it's the change in the amplitude, and then the parameter Q, which shifts the graph vertically either up or down. Let's recap. Let's look at the basics graphs that you have done in grade 10. So already you have done the graph of sine x. You know how to sketch the graph of sine x. You know that if you start your domains from x is an element of 0 degrees is to 360 degrees, you do know that it's going to start at 0. You're going to have your value of x as 0, and you're going to have the value of y is 0, and also at x is equals to 90 degrees, you're going to have your value of y as 1. And also at 180 degrees, when x is 180 degrees, you're going to have your value of y as 0. And when your x is 270, you're going to have your value of y as -1. And also, you're going to have your value of x as 360 degrees, and your value of y will be 0 degrees. So a sine graph, it ends at 360 degrees. And when you are looking at your graph, of course, you will notice that it ends at 360 degrees, but the value of x here, you will have 360 degrees is to 1. Whereas in the sine graph, you have 360 degrees is to 0. And then let's look at the graph of tan x. You will notice that a graph of tan x, it starts here and it goes like that. And again, you'll have your asymptotes at 90 degrees, and you'll have your asymptotes at 270 degrees. Now, this is only if your graph has been restricted the range to start from 0 degrees up until 360 degrees. Okay. Firstly, we'll start by looking at the effect of A. If there is a change in amplitude, the y values of the standard graphs will be multiplied by A. So if your graph, for instance, let's look at the standard graph. In the standard graph, when you are looking at your value of A, which is supposed to be here, the value of A there is just 1. So if your value of A or your amplitude is 1, then your value of y will be multiplied by that value of which is 1, and you'll have the y-axis as +1 and also that -1. Also here you'll have the 1, and also this side you have your 1. Those are your range. Also, this side is going to start from on your tan graph, it goes up until infinity. Remember, it doesn't end anywhere. It goes up until infinity. Also, this side, it goes up until infinity. Even this side, it goes up until infinity. So your amplitude doesn't affect the graph. So this causes a change in the amplitude by a factor of A. A change in the amplitude stretches the graph or compresses the graph vertically. Okay, so the graphs will be in the forms of y is equals to A sine x, and y will be equals to A cos x, y will be equals to A tan x. So now we have added this value of A, that value of A, and that value of A as your amplitude. But you have done this in grade 10, so this is just revision. Okay, let's look at example number 1. Example number 1, it says on separate axes, sketch the graphs of y is equals to -3 sine x, y is equals to 1 all over 2 cos x, and y is equals to 2 tan x, where x is an element of -360 degrees is to 360 degrees. So they're saying you must sketch these 3 graphs and your domains, they are restricted from negative 360 degrees up until 360 degrees. Let's look at the first example. So make sure that you watch what I'm going to do right now clearly, because the second example you'll be doing it. I'll give you time to do it. Ne? So you are given y is equals to negative 3 sine x. Let's start by sketching the mother graph, which is y is equals to sine x. So we'll sketch both this graph and also this graph so that you can see the difference that is going to be brought by that negative 3. You can see this side, the value of a is just 1, right? So let's see how your graph is going to change. Is it going to stretch, or is it going to be compressed? Okay, so I'm going to use my table method. I'm sure you already know how to use the method of using the calculator. Ne? So we are starting from negative 360. So I have my x values, I have my y values. How do you know the intervals that you're supposed to be using? So what you do, you'll say interval, it's equals to your period divided by 4. I'm sure you already know this from the previous lesson. So the period of your graph, yes, of sine x, cos x, it's given as 360 degrees. So your graph, it takes 360 times to finish the first circle. So 360 degrees divided by 4, it's given as 90 degrees. Ne? So it means you'll be using the steps of 90 degrees. Are we together? The steps of 90 degrees, or you can say the intervals of 90 degrees. So if we are starting our graph from negative 360, it's going to go to negative 270, and then also negative 180, negative 90, and then it's going to pass by 0. It's going to be 90 degrees. It's going to be 180. It's going to be 270 up until 360 degrees. Don't forget, these are degrees. Ne? These are angles. So you must put those degrees. Okay, so you take your calculator, you say sine x, y is equals to, where there is x, you substitute negative 360 degrees, and you'll get your value of y, of which it's going to be positive. So it's going to be 0. Ne? And then again, you'll say y is equals to sine, where there is x, you'll substitute negative 270 degrees, then you will get your value of 1, right? And then you'll say y is equals to sine negative 180 degrees, and you will get your 0. You'll just keep on doing this, ne, for all those values of x until you get all the corresponding values of y. So I'll just continue with these ones. So that's going to be negative 1, that's going to be 0. Then from 0 it goes to 1. Let me just double check. Sine into 180 degrees, it gives you 0. Then it's going to be negative 1, and then it's going to be 0. Ne? So let's sketch our graph. We are starting it from I think it must go up a little bit. Okay, so here I've got 0 is to 0, and then this side I'll have negative 1, I'll have negative 2, and I'll have negative 3. I'll have positive 1, I'll have positive 2, and I'll have positive 3. Make sure that you use your ruler, and the spaces in between, they are the same. Ne? So this side I'll have negative 90, I'll have negative 180, I'll have negative 270, I'll have negative 360 degrees. This side I'll have 90 degrees, 180, 270, 360 degrees. Ne? Okay, so now we can sketch our first graph, of which it's the mother graph of y is equals to sine x, right? So when x is 360 degrees, y it's going to be 0. So it's going to be on top of the line, because along this line, y is equals to 0, right? Okay, so at negative 270 degrees, I'll have positive 1, so it's going to be somewhere here. And then at negative 180 degrees, I'll have 0, so it's going to be on top of that line. At negative 90, I'll have negative 1, which is going to be somewhere here. And at 0, I'll have 0 is to 0. And then at 90 degrees, I'll have positive 1, which is somewhere there. And at 90, I'll have 0. And then at 270 degrees, I'll have negative 1, which is going to be somewhere down here. And then 360 degrees is going to be on top of that line of the x-axis. Now we can just connect our dots, ne? Or our points. So my graph looks like that. Ne? So my graph will start at 360 and it's going to end. It starts at negative 360 and ends at positive 360. This is the mother graph, the one of y is equals to sine x. Ne? But we were asked to sketch this one. So let's start and find the values of y when the amplitude has changed, or the value of a is now negative 3. What's going to happen to that graph? So the values of y will be, if I've got negative 3, you say negative y, it's equals to negative 3 sine. Where there is x, you substitute negative 360 degrees. Ne? You'll notice that your graph will be, the value of y will be it's going to be at 0. Okay, and then at negative 270, it's going to be at negative 3. And then at negative 180, it's going to be 0. And then at negative 90, it is going to be positive 3. And then at 0, it is going to be 0. And then at 90, it is going to be negative 3. And then at 180, it's going to be 0. Then at 270, it's going to be 3. And then at 360, it is going to be 0 degrees. So I don't know if you can see what's happening to this graph, or what's going to happen to this graph. The value of y, it was 1, but now it's negative 3. The value of y was negative 1, but now it's 3. It was positive 1, now it's negative 3. It was negative 1, now it's positive 3. Okay, let's sketch and see. So at negative 360, I'm still going to have the 360 degrees. So the 0 is y. At negative 270, I am still going to have negative 3. And then at negative 180, I'll have y at 0. And then at negative 90, I'll now have the point at y is equals to 3. And then at 0, I'll still have 0. And then at 90 degrees, I'll have negative 3. At 180 degrees, I'll have 0. And at 270 degrees, I'll have positive 3. So it's going to be somewhere here. And then at 360 degrees, I'll still have the 0. Ne? You just join your points. Okay, so it's going to go like that. You see, I don't have to cook anything. I just connect the points and my shape comes out as it's supposed to be. So you will notice that your graph has stretched how many units upwards? The first one, it had the range as y is an element of, it was starting from -1 up until +1. But if you are looking at the new one with a as -3, it is now y is an element of, it is now covering the 0, -3 and +3. So it's now at -3 is to 3. So the values of y, they have been multiplied by that factor of a, which is -3. So from -1, it has been multiplied by that -3. It is now -3. From +1, it moved to that +3. So it means even your range, they are going to change if your amplitude changes. So with this one, it changed from -1 to +1, and then it changed from -1 is to 1 to -3 is to +3. Okay, let's look at the next one. Y is equals to 1 all over 2 cos x. So I want you to find the values of y for this mother graph. Ne? So the intervals, they are going to be the same as the ones of that graph of sine, because remember the period of sine is 360 degrees and also the period of cos is also 360 degrees. So the intervals, I'll still have -360 degrees, I'll have 270, I'll have -180, I'll have -90, I'll have 0 degrees, I'll have 90 degrees, I'll have 180 degrees, I'll have 270 degrees, and I'll have 360 degrees. So what I want you to do for me in the next, I'll give you a minute. I want you to find the corresponding values of y for me and try to sketch the mother graph. Your 1 minute starts now. Okay, your 1 minute is up. Let me have these values of x. So if I substitute 360 where there is x, I get 1. Unlike the graph of sine, whereby when you substitute -360, you get 0 degrees, right? Okay, so now I'll substitute -270 degrees, I'll get 0. And then if you substitute the value of x as -180 degrees, you'll get -1. And if you substitute -90, you will get 0. And if you substitute 0, you'll get 1. Unlike the graph of sine, whereby when you substitute 0, you get 0. Ne? And then you move to 90 degrees, you get 0. And if you substitute 180, you get -1. And if you substitute 270, you get 0. And if you substitute 360, you get +1, right? Okay. Make sure your spaces in between, they are the same or they are equal. -360 degrees, -270, -180. negative 90, don't forget these are degrees, and then you say from negative, you'll have negative 1 and you'll have positive 1. So I have 90 degrees, I have 180, I have 270, and I have 360 degrees, right? Okay, so my first point of the mother graph, it's going to be when x is negative 360, y will be positive 1. So it's going to be somewhere up there. Ne? And then when x is negative 270, y will be 0. When x is negative 180, y is going to be negative 1. It's going to be somewhere down here. Ne? And then when x is negative 90, y will be 0. And when x is 0, y is going to be 1. And then when x is 90, y is going to be 0. And when x is 180, y is going to be negative 1. When x is 270, y is going to be 0. And when x is 360, y is going to be positive 1. It's going to be somewhere up there. So from there, what do? You connect the points. You connect the points just like that. So you'll notice this is the graph, of course, because here it turns at 0 is to 1. It doesn't turn at 0 is to 0 like the graph of sine, right? And also it starts from negative 360 is to 1, and also positive 360 is to 1. That point is not 360 is to 0. Ne? So that's my mother graph. And then from there, I need to sketch the graph that has a change in the amplitude. So the amplitude has been changed to be 1 all over 2. So it means the value of y now is going to be multiplied by what? By 1 over 2, right? So instead of having 1, now I'll have 1 over 2 as my value of y. So I have y here. If I substitute negative 360 in that equation of 1 over 2, you'll say cos of negative 360, you'll get 0.5. Okay? If you substitute negative 270, you'll get 0. And if you substitute negative 180, you'll get negative 0.5. So here it's going to be 0. And at 1, it's now going to be 0.5. At 90, it's going to be 0. Here it's going to be negative 0.5. And here it's going to be 0. And then here it's going to be 0.5. So these are my new values of y. Ne? So you'll tell me afterwards if this graph has been stretched or it has been compressed. Ne? Okay, so when x is negative 360, I'll have my value of y as 0.5. 0.5, it's going to be in between 1 and 0. So we can say somewhere here, ne, I have my 0.5. So at negative 360, I'll have 0.5. So it means it's going to be somewhere there. It's just going to be between 0 and 1. And then at negative 270, I'll have 0. And at negative 180 degrees, I'll have negative 0.5. So negative 0.5 will be between 0 and negative 1, right? So anywhere in between those two. So it means at negative 180, I'll have a point that is somewhere here. And then at negative 90, I'll have my 0. At 0, I'll have 0.5 is going to be somewhere here. And then at 90, I'll have 0. And then at 180, I'll have negative 0.5. So it's going to be somewhere in between here. And then at 270, I'll have 0. And then at 360, instead of having 1, I now have 0.5. So let's connect our points. So with this graph, you'll notice that it was turning at +1, but now it's turning at 0.5. So it means it has been compressed. Remember, when we are talking about the amplitude, we are talking about it compresses the graph vertically. So from here, it has been compressed to the 0.5. Okay? So if we are finding the range, you'll say now your range y is an element of, it starts from negative 0.5 up until 0.5. Unlike the mother graph, whereby the range, it was y is an element of, it was only covering from +1 up until -1, right? So it's -1 is to +1, and you have the square brackets because it starts exactly at 1 and ends exactly, or rather those points, they are included. The -1 and the +1, they are included. So you'll notice again, your A has changed the graph. It has compressed the graph with the 0.5. Moving along, let's look at the last example, which is the y, it's equals to 2 tan x. So again, we'll sketch the mother graph, which is tan x. And with this one, the intervals, it's going to be the period all over 4. And the period of tan, it's 180 degrees, right? All over 4. So it means you'll have 45 as the intervals. Okay? So we are going to start by looking at negative 360 degrees, negative 270, negative 180. Also, we are using the intervals of 45 now. Ne? So it's going to be negative 360, negative 315 degrees, and then you'll have negative 270, then you'll have negative 225, then you'll have negative 180, then you'll have negative 135, then you'll have negative 90, then you'll have 45 degrees, then you'll have 0 degrees. This one is a bit long, it's negative this side, ne? And this is 45. Let me fix it. Okay. So I still have 45 degrees, I have 90 degrees, I have 135, I have 180, I have 225, I have 270, then I have 315. Okay, I'll have to erase this side a little bit. So I have 315, and then lastly, I have 360 degrees. Whew, okay. So we know already that our graph of tan has got the asymptote at negative 270. So here we have error. And also we have 270 and also at 90. And then at 90, it's math error. You don't have to cram that. You'll see when you are substituting in your graph, you'll notice that it gives you math error. Ne? So your graph of tan, it shouldn't touch negative plus or minus 270 and plus or minus 90 degrees. So let's substitute. You'll substitute tan negative 360 you'll get 0 degrees. And then at negative 315, you'll get positive 1, and then you'll have met error. Then at negative 225, you'll get negative 1, then you'll get 0, then you'll get positive 1, then you have met error. And then at negative 45, you'll get negative 1, and then at 0, you'll get 0. And then at 45, you'll get positive 1, and then you have met error. And then 135, you'll get negative 1, you'll have 0, you'll have 1, met error. And then again, you will have at 315, you'll get negative 1. And then at 360, you'll get 0. Okay? So let's sketch our graph. So you have negative 1 and negative 2. You have 1, 2, and 3. Negative 45, you have negative 90. The spaces won't work. Negative 45, negative 90. You have negative 180 degrees. Then you have negative negative 135, you have negative 180. Then you will have negative 225. Then you'll get negative 270. Then you'll get negative 315. I hope you can still see. And then lastly, you'll have negative 360 degrees. Okay, and then let's put the values of x on the positive x-axis. I'll have positive 45, I'll have 90 degrees, I'll have 135, I'll have 180, I'll have 225, I'll have 270, I'll have 315, then lastly I'll have 360. Okay, so let's do the mother graph now. So when x is negative 360, I'll have the value of y as 0. When x is negative 315, I'll have the value of x as positive 1. So it's going to be somewhere here. And then at negative 270, I have my asymptote. Don't forget your asymptote. Ne? At negative 90, I have my asymptote. My graph shouldn't be on top of that line or even touch it. Ne? At 270, okay? And then at negative 225, I'll have negative 1 is going to be somewhere here. At negative 180, it's 0. At negative 135 is going to be somewhere here at 1. And then at, I think it's going to be a little bit down. And then at negative 90, obviously that's your asymptotes. At negative 45, I'll have negative 45, I'll have a 0. At negative 1. And then at 0, I'll have a 0. At 45, I'll have positive 1. And then at 90, it's an asymptote. And then at 135, I'll have negative 1. At 180 degrees, I'll have 0. At 225, I'll have positive 1. So it's going to be somewhere here. And then at 270 degrees, I'll have my y as met error, so that's my asymptote. At 315 degrees, I'll have -1. Then at 360, I'll have my 0. Ne? Okay, so let's connect our points. So my graph is starting at -360. It approaches the asymptote, but it doesn't get on top of it. Ne? It approaches the asymptote. It goes like that. And again, it goes this side and approaches this asymptote, right? Again, it approaches the asymptote. It goes like this. And again, it approaches the asymptote. This side, same thing. It approaches the asymptote like that. And then this side, since it started from this side, it went up. From 360, it's going to go down and approach that asymptote. So that's my shape for the mother graph, which is tan x. At 45 degrees, I have the value of y as +1. Ne? Okay, let's do the last one, the one of y is equals to tan x, whereby now the amplitude, or rather our a, has been changed to be 2. Ne? So I'll have negative tan into negative 360 degrees, I'll get 0. And tan into 270 degrees, (315), it's going to be +1. And then at negative 270, oh no, I'm substituting in the wrong graph, so it's -360, it's 0, and at negative 315, it is going to be 2, because now my a has changed to be 2. Ne? And then at 270, I'll still have my met error, of which it's my asymptote. At -22, I'll have -2. So this one will be 0. This one will be +2. This one will be met error. This one will be -2. This one will be 0. This one will be 2. This one will be error. This one will be -2. This one will be 0. And this one will be +2. And then I'll have error. And then the side, it's -2. Ne? Don't forget, from this equation, where there is x, we substitute these values of x. So, for instance, the negative 360 degrees, you'll say y is equals to 2 tan. Where there is x, you say negative 360 degrees, and you'll get the corresponding value of y. For negative 315, you still do the same thing. For negative 270 degrees, you still do the same thing. You substitute where there is x. Ne? Okay, so at negative 360 degrees, I'll still have a 0. And then at negative 315, I'll have a 2. So instead of 1, I'll now have a 2. So it's going to be somewhere up there. So initially, it was at +1. Now it's at +2. Okay, and then negative 270, it still met error. And then at negative 225, I'll have -2, so it's going to be down there. And then at negative 180, I'll have 0. And then at negative 135, I'll have 2. And then at negative 90, I'll have met error. And then at negative 45, I'll have -2. And then at 0, I have 0. And then at 45, I now have 2 instead of 1. At 90, I have met error. At 135, I have -2. It's going to be somewhere down there. And then 180. And then at 225, I'll have +2, so it's going to be somewhere there. And then at 270 degrees, I'll have maths error. And then at 315, I'll have -2. So it's going to be somewhere down there. And then at 315, it's going to be, or at 360, it's going to be at 0. So from here, you just connect your dots. Ne? So from here, it's going to go up. And then again, it's going to be like this. And then again, it's going to be like this. And then again, it's going to be like this. And then from here, it's going to be like this. Okay, so you'll notice that this point of 45 is to 1. That value of x, which is 45 degrees, is to 1. It is now 45 is to 2. It's no longer 45 is to 1, but it's now 45 degrees is to 2. Can you see that? From here, it is now there. That 45 is to 2. Okay, another thing, let's look at the domains. The domains x is an element of, our domains, they are restricted from -360 up until +360, right? So you open a square bracket because it's the -360, it's included, or it starts exactly at -360 up until the 360 degrees. These are all the values of x that are covered by the graph. Then you look at the range. Your range will be y is an element of, if I'm looking at my range, as much as we are saying with the one that has been, that has a change in a to be 2, it's now having that value of y as 2. When you are looking at your graph, you can see that it's going to be a continuous graph, or rather it's a continuous graph. From here, it goes up until infinity, right? And then from here, it goes down up until infinity. Again, it goes down up until infinity, and it goes up until infinity. We don't know where it's going to end. So you say your range, it's going to be -infinity is to +infinity. Then your period is going to be just 180 degrees. Why is it 180 degrees? Because you don't have this value of k here. It's just 1. It isn't changed. So it's still 180 degrees. Okay, and then if you move to your amplitude, are we going to say your amplitude is 2? No, we are not going to say your amplitude is 2. Why? Because remember, the amplitude, it's the distance between the resting point up until, you see, when you have your graph, of course, it's like this, right? Your resting point, let's say these are your x-axis. When you are looking at your resting point, you are looking at your x-axis, ne? So you are looking at the distance between your resting point up until that point, or the end point on your where it tends. So that's the distance that you'd be looking at, because we are talking about the amplitude. But in this case, we are looking at if you are looking at your resting point, and then you are looking at the end point this side, there is no end point. Your graph, it goes up until infinity. Even if you are looking from this side, this is the resting point, and then when you are looking at this side, you don't have an end point, because your graph is going to continue going down up until +infinity. So the amplitude of the tan graph, we just say it's undefined. Are we together? Okay. Let's look at the effect of Q, which is the vertical asymptote. So if Q is added to the graph, it will shift up by Q units. So in your graph of sine x, or in your graph of cos x, or in your graph of tan x, if Q is added, then your graph is going to shift Q units up. So it's going to go upwards. And then if Q is subtracted from the graph, your graph will shift Q units downwards. Ne? Let's look at these examples. On separate axes, sketch the graphs of y is equals to sine x plus 1, also y is equals to cos x minus 2, and y is equals to tan x plus 1, where x is an element of 0 degrees is to 360 degrees. Okay, starting with this one, I'll do the first one and then you'll do the second one. Ne? Okay. So I'll start with the mother graph. The intervals, they're still going to be the same. Ne? The intervals, it's still going to be the same because the period hasn't changed. So it's going to be the period of the graph of sine. You don't have any k here. So it's going to be 360 degrees divided by 4 and you'll get 90. So we're still using the intervals of 90 degrees, or if you are using your calculator, the part where they say you must substitute your step, you substitute the 90 degrees. Okay, so I have my x, I have my y. We start at 0 degrees. We have been restricted to start from 0 degrees. So it's 90 degrees, then it is 180, it is 270, then it is 360. This is the graph of y, it's equals to sine x. Ne? Okay, so if I substitute my 0 here, I'll get 0. And if I substitute my 90 degrees, I'll get positive 1. And then if I substitute 180 degrees, I'll get 0, then negative 1, and then 0. Ne? So this is the original graph. Let me sketch it here. So I'll have negative 1, negative 2, 1, 2, 3, and 4. I have 90, I have 180, I have 270, and then I have 360 degrees. So you will notice that at 0, you have 0. We have done this one. I'm just going to be a little bit fast. At 90, we have that. We have this. And then at 270, we have negative 1. And then at 360, we have 0. So it starts here. It goes like this. This is the original graph, or the mother graph of sine x, right? Okay, so now we need to find the corresponding values of y for which graph? For this graph, whereby now we have plus 1, right? Okay, so instead of starting from 0, it's now going to start at 1, and then it's going to be at 2, it's going to be at 1, it's going to be negative 1 to 0, from 0 to 1. Okay. Okay, so let's sketch the new value, the new graph, sorry. Okay, so at 0 degrees, I have positive 1. So at 0 degrees, I have positive 1 is going to be here. And then at 90 degrees, I'm going to have positive 2. It's going to be a little bit there. And then at 180 degrees, I'll have 1. So it's going to be somewhere here. And then at 270 degrees, I have 0. So at 360 degrees, I have, oh, sorry. So it's going to be somewhere here at positive 1. Okay, so from here, it goes like this. So you will notice that your graph has shifted from here to up there. So since you have plus 1, instead of starting from 0, it's now starting at positive 1. So it means your graph has shifted 1 unit upwards. And then also, when you are looking at this value of y, which is y, it's equals to 1, you can look at it as the new x-axis. So you had your x-axis here. Now your graph is turning at y, it's equals to 1. So you can take the y, it's equals to 1, this value, as your new x-axis, ne? Because now your graph is starting at positive 1, it's turning at 2 because it has shifted 1 unit upwards, and then the resting point is now at y, it's equals to 1. Again, at 0 because it has shifted from negative 1 to 0, and then here at 0 it has shifted 1 unit upwards. Okay, so look at y, it's equals to cos x minus 2. I'll give you a minute to sketch that one fast. In the meantime, I'll be doing my table. Remember, we restricted the domains to be from 0 degrees up until positive 360 degrees, right? So you'll have your x, you'll have your y. You start from 0 degrees, you go to 90, you go to 180, 270, up until 360 degrees. So you'll sketch the mother graph and also sketch the one that has been shifted 2 units upwards. You have 1 minute, ne? Okay, your 1 minute is up. Okay, so let's start with the mother graph, the one of y, it's equals to cos x. So we know that at 0 degrees, our graph of cos, it's going to have 1. And then at 90 degrees, it is going to have 0. Then at 180 degrees, it is going to have negative 1. And then at 270, it is going to have 0. And then at 360, it is going to have positive 1. So now it is shifted 2 units downwards, right? So you have the new x-axis as y, it's equals to negative 2. So it means you will now have cos x. Where there is x, you substitute, you'll say it's cos. Where there is x, you substitute 0 degrees, then you say minus 2, ne? And you'll get minus 1. So instead of turning at positive 1, it is now shifted 2 units downwards. It's going to turn at negative 1. Okay? And then at 90 degrees, again, you'll say it's cos into, where there is x, you substitute 90 degrees, you say minus 2, you'll get minus 2. And then at negative 1, you have negative 3. At 270, you have negative 2. And then at 360, you will have negative 1. So I am saying to you, you take this negative 2 as your new x-axis. So you were having your x-axis there, but now your x-axis, they are going to be somewhere there. Let's start by sketching the mother graph. You'll see what I'm talking about. So you'll have 0 is to 0. At 90 degrees, sorry, you'll have 0 is to 1. That's your mother graph. and then at 90 degrees you'll have 0, and then at 180 degrees you'll have negative 1, and then at 270 degrees you'll have 0, then at 360 degrees you'll have positive 1, so it's going to be somewhere there. So you start from there, you join your points, so that's your graph of cos, right? Okay, now let's sketch the graph of y. It's equals to cos x minus 2. So at 0 degrees you'll have negative 1. So your graph has shifted 2 units down. So from 1 it moved to 0, and then up until the negative 1. And then you have 0 degrees is to negative 2, so it's going to be somewhere here. And then 180 degrees is to negative 3, it's going to be somewhere here. And then 270, it's going to be somewhere here. And then at 360 degrees, you'll have negative 1, so it's going to be somewhere there. So your graph is going to look like this. You see? So your graph from here, it has shifted 1 unit down. So from positive 1, it shifted to negative 1. From 0, it is shifted to negative 2. From negative 1, it is shifted to negative 3. From 0, it is shifted to negative 2. From 1, it is shifted to negative 1. So your graph has shifted negative 2 units downwards. Ne? I hope you understand that. Okay, let's move. So you have the graph of y is equals to tan x plus 1. So let's look at the graph of tan when it is shifted 1 unit upwards. So now the new x-axis, it's going to be y is equals to 1. Let's start with the mother graph. So we are starting from 0, we are going to 45. Remember, we're using the intervals of 45, right? Because the period hasn't changed. So we move to 90 degrees, 135 degrees. You move to 180, to 225, 270, 315, up until 360. Okay, so we know that at 90 you have met error, you have your asymptote. At 270 you have your asymptote again. Ne? Nothing has happened on the... Okay, so at 0, I'll have, since my graph has shifted 1 unit upwards, you'll say, we are starting with the original one. So it's going to be at 0. It is going to be 45. I'll have my y value as 1. At 135, I'll have my y value is negative 1, at 0 is 1 met error, and then 315 it's negative 1, and then at 360 I have 0. Ne? So since my graph has shifted 1 unit upwards, it means it's no longer gonna start at 0, but now it's gonna start at 1, and then no longer at 1 but at 2, no longer at negative 1. But now I'll have my value of y at 135 as 0. And then at 180 it's 1. And then at 225 it's 2. And then at 315 it's going to be 0, and then at 0 it's going to be 1. Ne? So our graph is starting at 45, 90, 135, 180, 225, 270, up until 315. I don't have space for 316. Eh? So I'll have my mother graph at 0. And then my other asymptote at 270. So I have 0 is to 0, and then I have 45 is to 1. Then I have 135 is to -1. At 180 is 0. And then at 225, I have 1. Then at 270, I've got my asymptote. And then at 315, I've got -1. And then at 360, I'll have 0. Ne? So my graph will go like this. And then it will go like this. And then from here, it's going to go like this. I've been sketching the graph of tan. You can't lose marks for sketching the graph of tan now. Ne? You should be knowing how to sketch it. So this is the mother graph. And then it is shifted 1 unit upwards. So if it is shifted 1 unit upwards, it's no longer going to start at 0, but it's going to start where? At 1. And then when x is 45, is now going to be at 2. So this point here at 1, it's now at +2. Y is now +2. And then 90 is still the error, is still your asymptote. And then 135, your y is 0. And then at 180 degrees, you now have +1, so it's going to be there. This point is shifted to up there, and then this point here is shifted to be up there. And then 225, the point is shifted to +2. And then at 270, I still have my asymptote. And then 315, I have 0. And then at 360, I have +1, so it's going to be somewhere there. You'll notice that your graph is now going to be like this. And then from here, it goes like this. And then from here, it comes down like this. You see? So now, the new x-axis, they are at y is equals to 1. So the resting point, it's no longer y is equals to 0, but it's now at y is equals to 1. Ne? So your graph has shifted 1 unit upwards. Let's move to the parameter of P. So let's investigate the parameter of P. How does P shift your graph? Okay, example number 3, let's sketch the graph of sine x and the graph of x plus 30 degrees, where x is an element of -360 is to 360 degrees. So the domains, they are now restricted from -360 up until +360 degrees. We need to sketch this one, and then after sketching this one, we'll sketch this one on the same set of axes. Ne? Okay, we're still using the same method we're using. Let me just put my so I have x, and then I have y, So the values of x, we are still using the same steps because we don't have any k here. So the period is still the same, it's still 360 degrees. So the steps, we're still going to say 360 divided by 4, and we're still going to get 90 degrees. Ne? So you will have, let's start our graph from 0 to 90, 180, 270, up until 360. This is for the mother graph. Ne? So the values of y here, they are for the graph of y is equals to sine x. Ne? So these values of y, they are for this graph. So if I substitute here, I'll get 0. And then if I substitute here, I'll get -1. I'll get 0, I'll get 1, and then I'll get 0. Ne? Okay. I have 180 degrees to 70, and then I have 360. So what really happened to this graph? Let's see. Ne? So the mother graph, it says at 0 is to 0, we have a point. And then at 90 is to -1, we have a point. And then at 180, we have a point. And then at 270, we have a point. And then at 360, we have a point. Let me just double check something. Oh no, it's not -1, it's +1, so it's going to be, forgive my mistake, ne? It's +1 up there, and then you'll have 180 as 0, and then at 270, it's going to be -1, ne? And then at 360, you have the 0, ne? So your graph is going to go like this. That's your mother graph of sine, right? And then now let's find, or rather let's sketch the graph of y is equals to sine into x plus 30. You'll notice that there is a particular shift here. The value of x there, we take it as x is equals to -30, right? If you remember correctly in your functions, when you are shifting your parabola and when you are shifting your hyperbola, ne? So you'll notice that the shift, it's on the x-axis, it's horizontal. So here, in each and every value of x, I'll just subtract -30 degrees, because this is going to be the same as x is equals to -30 degrees, right? So the value of x there is -30. We take it as -30. So in each and every value of x, I'll go and subtract 30 and subtract 30. So I'll have -30, -30, -30, -30, and also -30. The shift is vertical, right? Okay. So what are the new values of x? Because now my graph has been shifted, horizontal, not vertical. I'm making a mistake. My graph has been shifted horizontally. So P, it shifts the graph horizontally. So if I subtract 30 and subtract 30 and subtract 30 and also subtract 30 and subtract 30, what is going to be my new values of x? It's no longer going to be 0 here, but now it's going to be -30 degrees. Here it's no longer going to be 30 degrees, but now it's going to be 60 degrees. At 180 degrees, it's no longer going to be 180, but it's going to be -150, sorry, +150. And then at 270 degrees, it's no longer going to be 270, but now it's going to be 240. At 360, it's no longer going to be 360, but it's going to be 330 degrees. So let's take those values of x and put them in our graph, ne? Or in our Cartesian plane. So just before -90, I'll have -60, let's say -30 will be somewhere just next to 0. And then at between 0 and 90, I'll have 60 somewhere here. And then between 90 and 180, I'll have 150 somewhere here. And then between 180 and 270, I'll have my 240 just somewhere here. and then 240 and 360, I'll have my 330 somewhere there. So when x is negative 30, y is going to be 0. So I'll have negative 30 is to 0. So this graph has been shifted from being 0 degrees is to 0 degrees. So this value of x, which was 0 degrees, is now negative 30 degrees. So I'll have negative 30 degrees is to 0. It's going to be on top here. And then at 60 degrees, I'll have positive 1. So it's going to be somewhere here. And then at 150 degrees, I'll have 0. And then at 240 degrees, I'll have negative 1. So it's going to be somewhere here. And then at 330, I'm going to have 0 degrees. So let's sketch our new graph. So it's going to start here. It goes like that. It goes like that up until there. You will notice that the values of x, they have been shifted. So our graph, it was going from here, but now it's starting from here. So it has shifted 30 units to where? To the left, right? So your graph has shifted 30 units to this side, from 0 to negative 30. It has shifted again from 90 degrees to 60 degrees. Again, it has shifted from 180 degrees to 150 degrees. Again, it has shifted from 270 degrees to 240 degrees. Again, it has shifted 360 degrees to 330 degrees. Ne? So when you are sketching such a graph, you have to keep on subtracting 30 from where? From the values of x that you are given. Okay, let's look at another example, example number 4. It says, on separate axes, sketch the graphs of y is equals to cos x and the graph of y is equals to cos into x plus 60 degrees, whereby the x is an element of negative 60 is to 300 degrees. Ne? Okay, so we're going to do the same thing that we did. We're going to start by so you have x, you have the value of y, and then you have the values of x. Your graph has been shifted horizontally, so now you have plus 60. So this you can write it as if the value of x here is x is equals to negative 60. So x, we take it as negative 60 degrees. So I have, we are starting from 0 degrees. We are going to 90. No. I must leave enough space. Okay, we have 180 degrees. We have 270. And then we have 360 degrees, right? So we are starting with the mother graph. The mother graph at 0, you are going to have 1. And then at cos into 90 degrees, you are going to have 0. And then at cos 180, you'll have negative 1. And then at 270, you'll have 0. And then at 360, you'll have positive 1, right? Okay. Let me do my Cartesian plane. So I have negative 90 here, negative 1, positive 1. So it's going to be 90, 180, 270, and 360, right? So at 0, I'll have positive 1. And then at 90, I'll have 0. And then at 180, I'll have negative 1. And then at 270, I have 0. And then at 360, I'll have positive 1. So it's going to be somewhere up there. Okay, so we start our graph from there. Smooth curve, and it goes like that. Can you see? Okay, so this is my mother graph of y. It's equals to cos x. So now we are shifting our graph by 60 units horizontally. All right? Okay, so what do you do to your values of x? You will say minus 60 degrees, minus 60 degrees, minus 60 degrees, minus 60 degrees, minus 60 degrees. Okay, so at negative 90, oh sorry, let's find the values of x first. So I'll have negative 60. At 90 minus 60, I'll have positive 30 degrees. At 180 minus 60, I'll have positive 120. And then at 270 minus 60, I'll have positive 210. And then at 360 minus 60, I'll have positive 300. Ne? Okay. So let me start with the first coordinate. Between negative 90 and 0, I'll have negative 60 just before negative 90. That's going to be negative 60. And then at 90 degrees, it changed, or it moved to 30. So I'll have 30 somewhere here. And then at 180 degrees, it moved to 120. So 120 is going to be somewhere, let me put it here. And then 270 degrees is just going to be just before. Okay, and then 300 is going to be just before 360. Don't forget we are dealing with angles, so it should be degrees. Ne? So when x is negative 3, it's negative 60, y is going to be 1. When x is 30, y is going to be 0. And when y is 120, y is going to be negative 1. And then when x is 210, y is going to be 0. And then when x is 300, y is going to be positive 1. It's going to be somewhere there. So our graph is going to go like this. It's going to go like that. So you will notice that your initial graph, it was starting at 360, but this one is now starting at 300. So this point 360 has shifted to be 300. The point at 270 has shifted to 210. The point at 210 has shifted to, sorry, this point of 180 has shifted to 120. The one of 90 has shifted to 30 degrees. From 0 degrees, it has shifted to negative 60 degrees. So you'll notice that your graph has shifted again 60 units to where? To the left. Okay, so the effect of P, the horizontal shift, in the case of a left shift, P will be added to the angle. The graph will be in the form of y is equals to x plus p, x plus, sorry, sine into x plus p, and y is equals to cos into x plus p, and y is equals to tan into x plus p, where x is an element of negative 360 is to 360. Okay, let's look at this example. The example y, you must sketch the graph of y is equals to tan x and y is equals to tan into x plus 45, where x is an element of negative 45 is to 315. I'll give you exactly 1 minute to do this one. 1 minute. Try to sketch the mother graph and also sketch the one that has been shifted 45 units to the left. Ne? Okay, quickly do this one for a minute. Okay, so your 1 minute is up. Let's start by sketching the mother graph. So remember, the intervals, they are going to be in 45, right? Because the period hasn't changed. So your period was, it's 180. So you say 180 divided by 4, then you'd get to the 45. Okay, so your graph is going to start at 0 degrees. We are talking about the mother graph, ne? So it's going to start at 45. Sorry, it's gonna start at 0 degrees. And then at 45, it is going to be 1. And then at 90, it is going to be error. And then here again, you are going to have your error. Oh, I forgot to put 270. So 270 is supposed to be somewhere here. Ne? So again, you'll have your error there. So at 135, you'll have -1. And then at 180, it's 0. And then at 225, it's 1. And then you have met error. Then you'll have -1, and then you'll have 0. So that's your mother graph. Okay? Okay, so you see you have 135, 180, 225, 270, 315 up until 360 degrees, right? Okay, so at 0 you have 0, and then at 45 you have 1, and then at 90 you have the asymptote. And then at 135, -1. 180, you have 0. And then at 225, y is 1. And then at 270, you have your asymptote. At 315, you have -1. And then at 360, you have 0, right? So your graph will go like this. And then it will go like this. This is the mother graph. You already know how to sketch this one. Okay, so now your graph has been shifted to the left by how many units? By 45 units. All right, so what are we going to do here? We'll say minus 45 degrees, minus 45 degrees, minus 45 degrees, minus 45, minus 45, subtract 45, and subtract 45, and subtract 45, ne? Right, okay, so I'll have negative 45. Here I'll have 0. And then here I'll have 90 minus 45 is going to be 45. And then 135 minus 45, I'll have 90. And then at 180 minus 45, I'll have 135. And then I'll have 180. And then we'll have and then at 270 minus 45, we'll have 225. And then at 315 minus 45, we'll have 270. And then at 360 minus 45, you'll have 315. Ne? So your graph here, drawing it from negative 45 is to positive 315. Ne? Okay, so the first coordinate is going to be when x is negative 45, y is going to be 0. It's going to be here. And then the second one, when x is 0, y is going to be at positive. When x is 0, it's going to be somewhere there. And then when x is 45, you'll have met error. So you are going to have your asymptote at 45. So your asymptote is no longer at 90, but now it is shifted to 45, right? Okay, and then 90 minus 45, sorry, at 45 degrees, you'll have met error, and then at 90 degrees, you'll have negative 1, so it's going to be somewhere here. And then at 135, you'll have 0. And then at 180, you'll have positive 1, so it's going to be somewhere up there. And then at 225, you are going to have, at 225, at 180, you have 1. And then at 225, you are going to have met error. So now you have your asymptote at 225. Okay, and then at 270, you have negative 1 here. At 315, you have 0. So your graph is now going to approach this asymptote, and then this side it's going to approach this asymptote, and then this side it's going to approach that side. Okay, so your graph has shifted 45 units to the left. So from this point of 180, it's now at 135. At 270, the asymptote has shifted to be 225. I don't know if I have mentioned this, the domains of the graph of tan. Ne? So the domains of the graph of tan, you'll say x is an element of, what are the domains? It starts at negative 45, right? Up until 315. So you take the domains that you are given. So it's going to be negative 45 degrees up until 315 degrees. Those are my domains. But my graph doesn't touch all the values of x, right? So there are some values of x whereby my graph is not supposed to touch, which we call the asymptotes. So in this case, you'll say, but x shouldn't be equals to, put that bracket there, it shouldn't be equals to 45 because that's my asymptote, right? And then also it shouldn't be equals to 225 because that's my other asymptote. So the domains of the graph of sine and the graph of cos, it's not going to be the same as the domains of the graph of tan. I don't know if I've mentioned that in the other examples, but you say x is an element of that particular domains that you are given, and then you say, but x shouldn't be equals to the asymptote. Are we together, guys? Okay. So you'll notice with this one, it is shifted 45 units to the left again. Let's look at another one. Okay, let's look at this one. So you'll notice with this one, you have y is equals to cos into x minus 90. X minus 90, it's a cofunction in the second quadrant, right? So it changes to be sine x, right? Okay, let's see if the graph is going to do the same thing as well. Okay. So you have x, you have y. So again, your graph has shifted. But now look at something there. My graph is now, the value of p is now negative 90. It's no longer plus 90. So it means that value of x will be x is equals to 90, right? So it means in each and every value of x here, I'm going to add 90 degrees. So I have my original value of x. I have 0 degrees. I have 90. I have 180. I have 270. And then I have 360 degrees, right? So with your graph of cos x, at 0 degrees, cos x is going to be 1, right? And then at 90 degrees, cos is going to be 0. And then at 180 degrees, it's going to be negative 1. And then at 270 degrees, it's going to be 0. And then at 360 degrees, it's going to be 1, right? This is my original graph of cos, the one of y is equals to cos x. Are we together, guys? Okay. And then now, my graph has been shifted 90 units to where? To the right, right? Because now it's x minus 90 degrees. So this value is going to be x is equals to 90. So I'll keep on adding 90 degrees, adding 90 degrees, adding 90 degrees, and adding 90 degrees, and adding 90 degrees. So I'll get my graph of y, it's equals to cos into x minus 90 degrees. So I want to find my values of x, my new values of x, because my graph has been shifted horizontally, right? Okay, so here I'll have 90 degrees, and then here I'll have 180 degrees, and then here I will have 270 degrees, and then here I'll have 360 degrees, and then this side I'll have 415. It's 360 plus 90. It's going to be 450. Oh, I didn't see the domains. The domains that are restricted from negative 350 is to 360 degrees. So it means we're supposed to start on the negative values of x. It's fine. I'll just include it from the graph. Ne? So I have 90, 180, 270, 360 degrees. Don't forget to put the degrees, positive 1 and negative 1. I have negative 90 degrees. I have negative 180, negative 270, and negative 360 degrees. Okay. So let's start with the mother graph, right? So with the mother graph at negative 360, you'll say cos x into negative 360, you'll get 1. It starts at 1, right? That's your mother graph. And then at negative 270, it is going to be 0. And then at 180, negative 180, it's going to be negative 1. And then it's going to be that. And then here it's going to be 0. And then here it's going to be 0. And then 180 is going to be negative 1. And then at 270 is going to be 0. And then at 360 is going to be 1. So my shape is going to be like this. This is the mother graph. You already know how to sketch the graph of y is equals to cos x, right? Okay, so now let's sketch the one that has been shifted 90 units to the right. Okay, so the new values of x, they are now at negative 360. I have to say plus 90. I'll get negative 351. Negative 351 is going to be somewhere this side. But they said, let me see if it's included. Yeah. So it's going to be just before negative 351. And then negative 270, I add 90. I'll have negative 180 is going to be somewhere here. It's already given. Okay, let me sketch on the other side. So at 90 degrees, I have 1. And then at 180, I have 0. And then at 270, I have negative 1. And then at 360, at 360, I will have 0 degrees. Okay, so this one, I'll have a point here. And then at negative 360, sorry for this. So I'll have a point that starts here. And then at negative 270, I'll have positive 1, it's going to go up there, and then here I'll have my point, and then at 90 I'll have my point here. Okay. What do you notice about this graph? Look at the starting point. Starting point at negative 360 is to 0. And also the ending point is at 360 is to 0, according to how we were restricted in the domains. Ne? And then also this graph, it passes through where? It passes through 0 is to 0. It's no longer passing through 0 is to 1. So this is the graph of y. It's equals to sine x. If you remember, in the previous examples, the graph of y is equals to sine x. It looked exactly like that. So if you have y is equals to cos into x minus 90, because it's a cofunction, it's gonna, because it's a cofunction, it's in the second quadrant, it's going to change to be y. It's equals to sine of x. You see? So your graph is going to look exactly like that. Okay, let's move along. In the case of a right shift, P will be subtracted from the angle. The angles, the graphs will be in the form of y is equals to sine into x minus p, y is equals to cos into x minus p, and y is equals to tan into x minus p. So when it's minus p, then now we are talking about the right shift, or the shift to the right. Ne? Okay, let's look at the summary. So parameter A affects the amplitude of the graph. Parameter Q, it shifts the graph up or down. If Q is positive, the graph will shift up. And if Q is negative, the graph will shift down. Parameter P shifts the graph to the right or to the left. I have explained that. Ne? So if P is positive, the graph will shift to the left. And if P is negative, then the graph will shift to the right. Please make sure that you pay note to this, because it's the new information. Make sure you practice, ne? So that you don't forget. And then for your homework, you look at worksheet number 1. You must sketch the graphs of each of the following functions on separate axes for an interval of x is an element of 0 degrees is to 360 degrees. You must make sure that you write down the maximum and minimum value and the amplitude of each function. Don't forget, if it's the graph of tan, you'll say x is an element of that particular domain or those particular values of x that you are given. Then you say, we must indicate that, but x shouldn't be equals to those asymptotes, or whereby your calculator is giving you math errors. Ne? And then indicates the coordinates of the intercept and the axis. And then you'll also look at worksheet number 2, of which it's talking about the shift in P. So it's the shift horizontally, either to the left or to the right. You'll just have to sketch those ones to make sure that you understood my today's lesson. Don't practice until you get it right. Always make sure you practice until you can't get it wrong. Okay, thank you.